with that, I would like to introduce Matt Peterson, who will be moderating for the panel discussion, to BNG or not to BNG. Mike is a co-founder at SF Mix and a principal at 2P, and he has gathered some excellent panelists. With that, let's welcome Matt. And please introduce your panelists. Thank you.
I'm going to do it in order here. Let's start off with Jared to come on up. And Jared, what's your name, AS, and organization?
Oh, yeah. Jared Mauch, Washtenaw Fiber, AS267, a couple hundred subscribers.
And next, Anton, TCAP. Ooh. Name, AS.
All right, Anton Kapela, AS 16842-2886, something in the 40,000s. There's a few out there.
Nice, and then we've got Nick.
Nick Bogle, Ziply Fiber, AS20055.
Okay, awesome. So with a show of hands, not that I can see with the lighting, how many folks are familiar with BNG technology, if you'd raise your hand? Okay, I can count.
That's a lot.
It's well, at least 10 or so. That's not so bad. So we'll start off here with some slides. These are not the most updated ones. We'll get those posted to the website here. The lesson learned is if you respond to a Facebook thread about what is BNG, you might end up on a panel. And that's exactly what happened here. We won't give credit to who the poster was. I didn't ask them. But they were basically inquiring about what is this IPOE thing. It has nothing actually to do with Power Ethernet. And is it some sort of like unnumbered loopback or some specific technology that's utilized in access networks? And that is true. So we're hoping to sort of provide some education around how that technology works and then some alternatives. So the outline, again, an older version of our deck, is really covering the basics of this. I'll try to go fairly fast with that. The intention is that you can download the slides and use it as a reference. Then we'll look at some examples of deployment of this technology, and then we'll go into discussion where hopefully I'll sit down at that point and not be leading as much of the discussion. So the first one is, how did this thread come to be? So not only did we have the inquiry with Facebook, Jared responded to a mailing list post on the JNSP list. And Jared basically provided an approach to logging prefix discovery, prefix delegation in an ISP environment. And if you remember the flow down there, with IPv6, we're not doing that. So customers receive a link local address, and then there's prefix delegation for the LAN side. And oftentimes ISPs need to log this for debugging and other telemetry. So Jared's response started off with a config. The config happens to be some end-of-life software, but still is well known and very well documented. And then it's some pretty large configuration files. I think this one is about 80 lines. I don't have the exact numbers in front of me, to basically log some of that additional information. And then there's a massive Python script that I've completely removed and commented out here. At the end of the day, the goal there is to get the customer source MAC, the host name of the device, what OLT they landed on, the MAC address of the OLT, other underlying and identifying information, and again, the V6 example there below. So why is this important? So it turns out that for access networks, they want to offer different types of services, different tiers. Typically, that's like a policer or a rate limiter, and the technology is constantly changing. If we look at some of our panelists, there are still folks using MoCA, which is an IP networking over coax technology, but there's also next generation fixed wireless like Cambium or Tirana. So the access layer is constantly changing. But an ISP wants to have a consistent way to manage both policy and routing. And then finally, I think Anton brought this up in one of our earlier calls, is we don't want customers impacting each other. We want to try to limit that blast radius as much as possible. So the example that we're going to give here is a PON network. This could equally apply to other access layer technologies. We're assuming that the customer is bringing their own Wi-Fi router, and we also assume that the provider has some sort of active demarcation equipment that the provider manages facing the customer or the subscriber. So as we walk through here, we've got, again, a subscriber with a laptop or a phone, some sort of mobile device. They're connecting to a Wi-Fi router. Industry terminology is technically called a residential gateway. Again, the customer is providing this as a BYO experience, so we don't know their WAN MAC address. We have no control over the Linksys-like visual here. And then we're plugged into some sort of passive infrastructure that eventually gets to active infrastructure. So there could be splitters and other things in the middle here. In this example, we've got an optical network unit. That would be an outside device. You might have heard of an optical network terminal. That would be the inside device. Sometimes it's known as a NID or a CPE, but basically it's some sort of active equipment that demarcates the customer. And again, in a PON example, we're plugged into effectively a switch or an optical line terminal. This is basically a managed layer 2 device that does really simple layer 2 capabilities. So the secret sauce of BNG is really implementing policy in routing. So it has basically two connotations at both layer 2 and layer 3. So in this example, the residential gateway is discovering the network. It's going to request standard DHCP options like subnet, IP address, gateway, etc. The packets are going to flow to the OLT. The OLT may choose to separate subscribers by VLAN tags. It may push or pop VLAN tags. Oftentimes it will append the DHCP requests with underlying information. So what port the packet came on physically, the MAC address that the port landed on, not just the subscriber or the source MAC. So again, identifying information, and eventually that hits a BNG. The typical BNG workflow is that identifying information is handed to a radius server, and the radius server basically does a lookup. And so that username could be an encoding of various MAC addresses, other option 82 information like serial numbers, etc., VLAN tags, and then it looks for a response. And based on that response, it will put the subscriber in a particular routing table or a particular rate limiter. So basic layer 2 approaches. In this case here, we can show an example. This is a Junos example, but this would equally apply to other vendors. Is those come in just like any other physical or logical interface. There's a demux interface. This interface gets created in a dynamic fashion. I don't want to spend too much time on the configs. Again, you can look at the slides as a reference. Walking a little bit down here to a little bit more detail, not only did we have the physical interfaces for some of the policy, again, this is some of the radius response information. So you'll notice there's a profile name, there's a VLAN tag, there's a policer or a rate limiter. All that is provided as a response based on that radius lookup. Same thing for layer 3, which DHCP pool. You can see the identifying information there is the agent circuit ID, remote ID, so the physical interface, colon, and then the VLAN tag that it came on. And then when we look at the actual BNG interface that's facing that network, it looks pretty similar to a normal physical interface. We've got flexible VLAN tagging that matches Q and Q, but there's a special auto configuration section. And in this example, it's saying, okay, we will take an outer range of 100 through 99 and an inner range of 255 to 2500. We're going to look for DHCP-v4 packets, and we're going to map that to a particular profile. So this one happens to be called L2 profile tagged. Same thing here is that you could also match static customers by VLAN tags outside of that range. And what does that look like? So this auto configuration, again, that's a Juniper specific terminology, basically is like a macro that gets expanded. So when that radius request comes back, this is what gets expanded, and that demux interface gets created. A lot of caveats here. So this is actually IPOE, meaning that we're looking at Ethernet frames. It was not encapsulated in PBPoE. Ironically, we didn't show any examples that showed V6. I didn't show you the config for the radius or defining any of the policers or shapers, so it's a really basic config. But if you look at other vendors, it's very similar stanzas, if you will. And the reason we wanted to do the introductions a little bit later is for folks to understand what BNG technology can or cannot do. So we'll spend a few minutes for each of the panelists to talk more about how they're using some of their access layer technology, how big the customer base is, the type of customers they're supporting, and of course, are they a fan of this type of technology? Conveniently, we're going to start based upon sequential AS numbers. Jared has the lowest one, so he will start.
Yeah, I guess I'll give you, quick version. I need to, as usual, I usually need to update the maps because they're a little bit more built out than what's shown. But, have a mix of customers on GPON, XGS, and a couple active Ethernet. I'd say primarily residential. There's a handful of business customers that I have, including at least one other wireless ISP who I actually sell, a DIA type service to as well. So he has his own towers and subscribers that might hang directly off of my network. But really, my goal was what I'll call the ultimate KISS principle, which is I run a DHCP server. Go and have that go out. I use the Ubiquiti PON gear because it kind of hits that right market segment. I'm using some Juniper for L3 now. I originally started off with a really, really old Arista thing, and customers, if they don't have a router, we end up giving them one of the Arrow, I think it's the 6 Plus or something, which has 2 Ethernet ports, which is nice because we can daisy chain those together throughout the house or whatnot to make sure that you can actually, instead of having wireless pods, you can actually run a cable between them as well, which gets better reliability for many of the devices. And then a lot of it is built with the same free open source software type of stuff. So yeah, even though the ISC DHCPD is something that they say, hey, maybe we'd really love you to migrate to Kia. The logging config that I have put together, that came at a lot of expense and time of getting that to work just right, to kind of piece everything together. But it works out relatively well. And then there's a when you look at this, yeah, it's definitely not obvious, which is why I literally just posted it in response to that person, where I said, here, this is what I'm doing, logging, a bunch of this, information. And it's especially because the DHCP v6 spec allows up to 32 agent relays, because apparently we do a lot of relaying of DHCP. And the ISC DHCP daemon, in order to do that, you have to make sure you reference the right relay information. So,
now, one thing I wanted to point out is the example that we have on this slide. I believe this is one that you provided, the Ubiquiti OLT, adds this option 82 information. And a lot of OLTs will allow you to customize that. You can do different delimiters or spacing or whatnot. But I think what's interesting here, to segue to our next panelist, is that you have access layer equipment that facilitates some of this underlying discovery information, where I think our next panelist is using more traditional kind of campus chassis devices that may not have this functionality. So why not do TCAP?
That's a real soft way to say it doesn't exist, and you're on your own. Thanks, Matt. You all know my name, Anton. So this collection of green stuff on the map does not include metro fiber. I figured bigger is better, so we'll just go with that first. Obviously, Madison City is where this whole collection of ASs and providership really focused and originated. Combination of MTU, so multi-tenant buildings, multi-dwelling sort of buildings, so high density, so 20, 30 to 200 or 300 units per building. So when I think of efficiencies, I think along those lines. This is in real contrast to, call it homes passed per mile being in the single digits and stuff that folks are typically engaged in the super rural spaces. So we're primarily this collection of whole buildings, whole neighborhoods, all kinds of stuff that goes to the level of neighborhoods, homeowners associations, whatever supports this sort of bulk purchasing activity. And within all of these different ASs are various cones of things that are all essentially matched together and share a common backend. And when I think of the backend, that really is the stuff on the bottom of this slide here, the operational aspects. So unlike the flexibilities maybe or the configurabilities one gets with abstract broadband network gateways, we're faced with the question of how to provide reasonable addressing efficiency across a variety of vendors, everything from the MikroTiks, the low-end Ubiquiti stuff, Cisco, lots of Juniper out there, and I want to drive it with just a couple common things, DHCP. I don't want to do a lot of config. I don't want to have service techs or field folks know about subnets per building, air quotes. Stuff like that is just a trap, I find. And so we want to avoid as much as possible those sorts of embedded uniquenesses, if you will. And so to achieve a lot of that, and we don't have the slides to show the configs today, we wanted to stick with just the thrust of the main points here, and that is to suggest that the mechanisms that really make this work are simply stated as IP unnumbered interfaces, and this is true for v6 and v4. If one goes and searches abroad or out there, they'll see examples of this with all the common and popular vendors alike. And the real bit that makes this all work well is simply being able to share IP topologies across a disparate number of layer 2 topologies. So when we talk about what does this mean, layer 3 per building, layer 2 stuff breakout, we point back to the first slide. One of the points that we raised was don't let a single customer, risk the entire property or block or neighborhood or city. So whatever you plug in, if it's not what I expect, if it doesn't just do a DHCP discover, I'm going to ignore it. And if you flood the layer 2 network area, that's great. Maybe I have a congestion potential after 30 people do those sorts of things in one uplink and so forth. But we try to focus on keeping separability where possible at layer 2. And then, again, with unnumbered conveniences in DHCP relay, option 82 injection being part and parcel to sorting this all out, now the Anycast service layer being just DHCP-D is pretty simple and straightforward to make reliable across a pretty large geo. And so we don't have to rely so much on a single set of backends like some large MSOs seem to still do in certain parts of the US. We can actually take one down, replace it, do things, and have it all live in the actual tables that matter in a database. And then that helps, of course, drive CSR tools, provisioning systems, billing, tracking, you name it. Whatever you need to do, we can actually go to a table of truth and get that out of it.
Okay, and then we're going to move on to Nick. Again, we're doing it by AS number. It happens that Nick is representing an organization that's slightly different scale than our first two panelists.
Mm-hmm. Yeah, so I run our network systems and network automation team at Ziply, and so we handle all of the radius infrastructure, DHCP infrastructure, and all of the what I would say are traditional kind of OSS stacks that you would see in a larger ISP. So we're around 500,000 subscribers. We do a lot of XGS and GPON across a bunch of different vendors. We do active Ethernet. We do DSL. We have some fixed wireless as well. And we kind of do all of the spaces, residential, business, enterprise, and wholesale. We're primarily based in Washington, Oregon, Idaho, and Montana. And we have a lot of legacy infrastructure as well as a lot of new infrastructure. And what makes us different than probably the other panelists is we have a lot of teams that handle all of the automation, monitoring, integration, and whatnot that goes on with what traditionally might be, a more complicated stack, but doesn't have to be. So we primarily use Juniper BNGs. We shape at the BNG, and we have plenty of capacity between our OLTs and our BNGs, as well as our BNGs and our core. But we also, doing that, we typically aggregate, 20,000-ish subscribers on any given BNG. And so hierarchical queuing is important, mostly for the shaping of those customers on many different rate plans. Yeah, so.
Sounds great. So I think one of the first topics that Anton has mentioned is this separation of trying to limit the blast radius or customers impacting each other. Starting with Jared here, I know you didn't have a moment to talk more about sort of the underlying configs, and again, that will show up on the updated slide deck. But my understanding is you're very dependent on the OLT and ONUs effectively to provide some sort of client isolation, and then you have a common layer 2 interface with a /24 or something like that.
Yeah. So the ONU actually, at the customer's home, actually inserts in the option 82 information into the DHCP request as it gets encapsulated, going upstream on the PON segment, and then, when it hits the Junipers, then it gets forwarded into the DHCP server as well. But yeah, Ubiquiti does have client isolation. They recently released in their 4.8 firmware MAC limits as well. So you can say, oh, this port can only have 3 MAC addresses or whatever visible on it. And that was kind of a long-awaited feature because a lot of people use that as a proxy for, one MAC address equals 1 IP address. Whether or not that's the right association is, I think, a subject for, maybe a whole separate thread of how do you configure, your DHCP and other infrastructure correctly, which is separately, challenging and such. But that allows us to limit, a lot of that potential negative behavior, and then those devices also have DHCP guard and RA guard, so we don't get RAs from the customers, and we don't have customers plug in their router backwards, or in the case of the Arrow, it literally behaves the same way on both Ethernet ports, and it detects which one is the WAN.
Right. And I think the concern around a large number of MAC addresses is oftentimes you may have a subscriber that's plugged in their internal LAN, and like their printer and other devices don't necessarily need a public IP, so you want them behind a gateway. So this,
I've certainly seen that.
it definitely happens. So to summarize, your access layer technology is providing some client isolation.
Yes.
And then it's still served from a common layer 2 domain, so common subnet or prefix.
Yeah, and I'm either lucky or dumb enough, I'm not sure which, where I have 2 VLANs. I have, the kind of the residential customer VLAN, and I have a business VLAN, which is where, if you have a static IP address or something, you kind of live over there on that VLAN.
Great. So Tony, I'm really interested in hearing how you prevent resource exhaustion, such as a DHCP pool being consumed, and again, how you're doing client separation. Is it VLAN tagging or some other strategy?
Well, yeah, back to the earlier couple points in slide references. Insertion is critical to know logically what the thing is facing the unknown entity, that is the customer interface. We might see link up and 1 MAC address, but they can arbitrarily drive client ID behavior all they want. All kinds of stuff can do stuff at the DHCP, I hate saying application layer, that we still wouldn't count at layer 2, right? So that's, again, a back-end systems, robustness, hardening sort of configuration exercise. But working up from physical layer, layer 1 stuff, debounce interfaces, interface event damping, all kinds of stuff like that is relevant. It is literally Ethernet ports to all users, and that count we showed earlier, 50,000 or so, might be customers we know about, and a lot we'll never know about. It could be 300 units in a building that's included, in their rent. We'll never know the name, don't know what it is or who. It's maybe a unit ID at most. And so resolving this in separate Kali discussions is worth bringing up later. But from the physical layer up to layer 2 and layer 3, all we've looked at and really tried to answer with available tools is what would happen in the worst case at layer 1, layer 2, layer 3. And to the point that we raise with layer 2 behaviors, beyond just policy stuff for transmit rate shaping, receive rate shaping, one can do nice things like specifically concern themselves with unknown unicast inputs or multicast inputs. Why flood the uplink ports to building infrastructure and so forth in the MTU or MDU space, and so on and so forth. And so from this layer forward then, once we know we have something deployed or, if you will, leased to a given subscriber, now it's a question of layer 3 stuff. So converging things and redistributing route information into the IGP is the next important step. And again, another reason to normalize and try to minimize that sort of noise, call it constant behaviors, that would allow instability to creep in or perhaps perturb higher layers is to certainly be minimized there.
So it sounds like your physical layer doesn't have splitters, for example. So in the case of PON, you have one output port and you may have a 32 or 64 by 1 or whatever splitter ratio. You clearly need that identifying information.
Right.
But in your example, it sounds like every customer or subscriber has some physical port. It could be coax or copper or something else. And then you're using that device to, again, append some identifying information.
Absolutely, yeah.
But you don't have a common layer 2 that they're sourced from.
No. So layer 2 is separate per port, VLAN per port. That might come in Q&Q. That might be just a straight large trunk port to a layer 3 edge device of some sort in that metro area or in that building. In many cases, this could be an entire city block of, say, singularly owned housing, for example.
Right.
So one developer might have N buildings. Okay, well, that's logically one contract interest. And so ActiveE looks like a router at that site, but it's really just originating /32s or 128s as they are handed out to the individual users.
So another interesting point, as I'm assuming, and I want to definitely get to Nick and others too, is it sounds like the vast majority of your customers are behind CGNAT.
Yes. Well, again, it depends. Okay. Some buildings are at the time where DFZ everywhere was the only thing we would ever do.
Okay.
Other locations are radically different, and it's now CGNAT by default, and exceptions are handled through account activity.
Great. So again, kind of scaling up to a larger scale. Nick, how are you solving some of these problems? Again, separating both the resource exhaustion concerns and also able to apply policy like speed or QoS.
Yeah, so in our environment, every customer ends up on its own VLAN, whether that's Q&Q or on a straight VLAN, like Anton mentioned. Typically, it's Q&Q. Every subscriber has a VLAN. Actually, every port on an ONT has a VLAN. So even if there's a 4-port ONT at a customer premise, every port actually has its own VLAN. And those end up getting tunneled back to the BNG, typically with MPLS pseudowires. And we break them out using demux interfaces, like we looked at in the BNG configs earlier. And we use Radius to essentially authenticate that customer into the network using DHCP option 82 information that is added typically at the ONT layer, or at the DSLAM layer, or at the wireless radio layer.
So I'm curious, how big are those pseudowires you have to build?
It depends on how we do it. We have two different topologies deployed right now. One that's pseudowire head-end termination. So they're actually just pseudowires to essentially another virtual interface. So those are just typically the uplinks to the BNGs. Other times we do essentially EPLs from OLTs. So if an OLT has 4 by 10 gig uplink, it would be 4 by 10 gig to the BNG. We're trying to be a little bit more port efficient and allow a little bit larger uplinks to OLTs. Working towards 100 gig OLT uplinks. Just for we don't really have a need right now to do that, but we want to make sure that as the network grows and additional customers or higher speed packages are offered on those OLTs, that we don't have any congestion. So from a policy perspective, though, we implement essentially access into the network via Radius with option 82 information, and that depends on the vendor, right? So we have built essentially the way our Radius handles authentication is dependent on vendor, and we have different formats. So for example, in our Nokia OLTs, we actually pass in a device identifier and a port identifier that gets written on the option 82 value. And then other times it might just be the PON port and ONT number, or it might be the ONT serial number. There's a number of different ways that, depending on the vendor implementation and how much flexibility you have in overwriting the option 82 data, what we can do. But based on that, it'll respond with an authorization and with attributes, right? So the attributes that it responds with are essentially, what firewall policy am I using? What IP pool am I pulling from? What QoS policies am I going to apply? And those differ, depending on if they're business or residential. They might differ, based on technology. If we don't do that a ton, but it would be very easy to do, where you have different policies for different technologies. And all of that comes back from Radius, and all of that logic is handled within our Radius stack. So we can apply the business logic at the Radius level to apply the policy that we need to, right? The customer has a 100 meg package, they get the 100 meg QoS policer. They're a residential customer, they get the residential firewall rules applied. So yeah, MAC limits are handled by just a limit of two IPs, typically is what we do. It doesn't matter if they're the same client or another. And flooding is applied via the firewall policy as well. We do, just any kind of thing that could overwhelm the control plane is rate limited using the firewall policies applied on the DMUX interface.
So one of the things I found fascinating between the panelists is just different ways of protecting that user. And so to summarize, it sounds like Jared is using a lot of technologies very specific to that access layer that's facing the customer. Again, a common layer 2, but that's not really shown or exposed to the customers. Anton, you've got a more stronger layer 3 routed network that has a lot of the typical controls that we would see there. And then Nick, you had mentioned pseudo wires, for the audience is, a tunneling mechanism to tunnel layer 2 over layer 3 in a redundant fashion if needed. I'm curious for the first two panelists, when some of those more advanced technologies would be justified. So for example, with Jared today, you just got a trunk facing your OLT. As your network grows larger, say you have a ring, for example, or in the case of Anton's deployment, where you've got multiple MDUs throughout the city, I could imagine that your topology could have different paths east to west. So are there some side effects or trade-offs of implementing some of that? And again, starting with Jared, when do you think you would graduate, if at all, from the trunk that's just facing your access layer equipment today?
I think it really depends on at what point I scale out of the ability to get either contiguous IP space or DHCP pools, or at what point I try to force or permit doing like CGNAT on top of the behaviors. So right now I can see growing 3-4x in size without, and still largely keeping a similar L2 topology. So when I go and I hand off from my L2 topology, I've got routers that redundant uplinks with VRRP and stuff like that for the customers, on those different VLANs or IRBs, and then you end up plugging in a whole bunch of OLTs. Well, those can be backhauled over Metro Ethernet, either over 1 gig or 100 gig or 25 gig BiDi optics, into that same centralized location that's doing everything. And since you have that physical hierarchy, it makes sense to do that because everything gets aggregated before it goes into the data center or to the transits. So right now I just do that with simple Ethernet switching, and I keep an eye on what things look like for the MAC table scale for those VLANs and such. And it's not right now. That's not something where it's at risk, where I need to go and isolate those for any reason. If I needed to, then quite often, given that a lot of the hardware I'm acquiring off of secondary market, sure, such as eBay, it might be as simple as, oh yeah, just throw a little more hardware at it than something else, or just split the PON segments and divide them up such that you're not exceeding the scale limits of the hardware.
Got it.
Can I ask so I have just out of curiosity, so growing your current deployment model 3 to 4x, like you said, do you not see any issues with any nefarious users or even potentially unintentional doing like a static IP binding to something in your pool and taking another customer offline?
I mean, the DHCP software, if it finds that IP is not really usable, if it says, oh, hey, this isn't allocated, to who I think it is, it'll hand out a different one. And since, we got the MAC limiting stuff recently, there's opportunity to, clean that up. And then once you identify the subscriber, you just go and, shut them off. And since, I hate to say it this way, but in a lot of the area, I'm the monopoly provider, or I'm the only high-speed option. I've been able to just communicate very clearly with customers, be like, they've asked me, I remember one customer specifically was like, hey, they mentioned torrents. And I was like, okay, you're asking me about torrents. And I said, well, if you get a DMCA notice, I'm going to have to forward it to you.
Diplomatic.
Which was a very diplomatic way of saying, don't make me have to shut your access off. And sure enough, at one point, I did get a DMCA notice, and it did happen to be that same person. And they did happen to get that email forwarded to them. So it's, that's not to say that, the customer equipment, doesn't behave badly or oddly, but, we've not had it be such a situation that it's taking off large portions of the network. We faced larger threats from like the physical, from physical things, animals, humans, damaging fiber from, other construction activities than it's been something where somebody's networking equipment misbehaves. I do happen to think that the Synology router my one customer has that DHCP requests every 30 seconds might be a little aggressive, and I kind of want to just not hand him a lease anymore, but I haven't quite gotten to that.
Okay.
Yeah, if it's not already clear, part of the reason we're not walking through a lot of configs and looking at PCAPs and that sort of thing is a lot of these questions are really around the scale of the organization and the type of access that you're providing. Jared was sharing earlier today that in a lot of cases he's helping his customers, farms and other agricultural environments build their inside plant, fiber between buildings or helping them with a Wi-Fi mesh router. I would assume for Anton, with MDUs at the scale that you're at, you're trying to not necessarily know the customer by first name and have that type of relationship where you could drive over and say, hey, stop torrenting. And I assume the same for Nick is at a very
I know
different scale.
every one of our 500,000 customers' names.
Yes, exactly. Yep. The ultimate teacher.
Postcards. Well, so to the question you asked earlier, Matt, and the scale is the one that really always matters here in terms of what we plan and what I want to forecast into. And so there's two things that factor into a lot of what sub-regionalization, if you will happen as this network, I can't say my anymore, but as this network grows, and it does grow through acquisition largely, so other ISPs become borged in, if you will. And in those cases, two things that matter are capacity overall. Where can I get that east-west capacity? What is it? And then what's the FIB consequence? Call it the forwarding scale consequence, okay? So if this is a largely just block level, city level, subclustering, then we'll stretch some layer 2 a little bit here and there and just do the usual stuff you can do at layer 2 to make that work well. Lags, bundle Ethernet, whatever.
QNQ, other.
Exactly. But then when it comes to that layer 3 edge and the DHCP magic, again, at some point, I don't like the idea, but we live with the idea that customers can directly influence IGP state. Okay, this is almost like multi-homing with your users, but with DHCP in a way.
Okay.
Because when they're there and answering, or refreshing the lease, they're in the FIB, right? And they go away, it leaves the FIB. Well, we did this with dial-up pools back in the day. We've done this in a lot of ways with even worse protocols. So I'm not really worried about that. But to me, that's the only real, call it, slider and dial gauge that directly informs when to say when along those lines.
Got it. So a lot of your policy is happening more at the layer 3 side and less on like OLT-specific features that trigger like a MAC learning to
And so this is, yes and no, and this is one of the pills we had to swallow, and that is to say some of the QoS stuff and call it service profiling, we had to put to the edgemost interface, to the customer-facing port. Right. It doesn't really associate layer 3 stuff so much, right? You might know the VLAN and the option inserted stuff from physical interfaces or VLANs that get seen by host configuration. But then layer 3 stuff just needs to ignore all that policy stuff. And so from an OSS, BSS account management point of view, if it's beyond bulk, again, if it's not one for everything, then pushing policy into 2 different places might be an operational initial tough pill to swallow for some teams. And when I say some teams, it's like some parts of the companies don't like to do that. because their style was very different. And I said, well, we gotta have concessions and agreement, and this is how we're going to get there. And so in some cases, almost all cases, that's the split we had to accept. So layer 3 stuff comes from this backend facility, this underlying data source, but policy for layer 2, port enforcement, that kind of thing, speed policy, it's paired with it, of course.
Sure.
But it's physically flowing somewhere else. So I can't just say OMC solves it all. I can't just say DHCP solves it all, unfortunately.
Yeah, I think
There's no radius unification here.
I think a common design pattern I see a lot of wireless ISPs is they'll start getting into PON, they'll buy equipment like Ubiquiti or others. They'll be dependent on that equipment to do like the MAC enforcement, the limit, or even the rate limiting or policing. But what's interesting at BNG is that can also occur at layer 3. So I'm curious, Nick, in your deployment, are you doing rate limiting at the layer 3 portion that's facing the internet or at the layer 2 portion that's facing that customer, or both?
So we do both, actually. On most platforms, we do only at the BNG in some circumstances, but generally at both. Big reason for that is if a customer gets a DDoS attack, you don't want to be forwarding it all the way through your access network. We'd rather, drop the traffic at a BNG that has several 100 gig or many 100 gig uplinks, and not take that to, a 1 gig DSLAM or worse that might be fed somewhere in the network, right? And kill all the other customers while we're doing it. Just for the time before it gets mitigated, right? Pretty short amount of time, but there is time there always. And sorry, what was the other part of the question?
Well, we can move on because of the time we've got left here. We can start actually, Nick, with prefix mobility. You were talking about the size of your pools. This is mostly a V4 question. Or is that basically focused on a certain geography and it's big enough regardless of the access layer technology? Or how do you move IP blocks around? How often do you have to do that? It's, again, common design pattern for a wireless ISP is they've built some mountaintop, they put some IP space there, now it's grown, they have to resize the DHCP pool. This is not true with a lot of fiber networks, but I'm curious, since you have a background in both, how do you guys apply, I guess, efficient ways of managing your IP space? And then the bonus question is, how do you provide public static IPs?
Yeah, so on, as far as the IP management in BNG, in our BNG deployment, is we aggregate a number of central offices back to one central office where we can get to about that 15 to 20,000 subscriber mark. And so we typically have a pretty standard deployment size of block that we go for. And then once you get to that size, we try to split out into another BNG somewhere in the area that we can kind of start that over again. But compared to, say there's 15 or 20 sites that might each have 2 OLTs at them, we're not applying on a per device level or at a per site level a prefix. We're being able to aggregate it all back where we have less waste just sitting around, waiting for an IP, because a customer can shift from one market to another, and there are larger blocks to deal with. It's a little bit easier to manage the capacity there. In the WISP space, it is very common to, at the top of your tower to have a /26 or something that you're assigning customers out of, and then all of a sudden, you have a ton more customers and you have to add another 26 and another 26, and then you're like, well, this is all over the place. Maybe I should try and combine it. And then you're like, oh, this tower is too overloaded. Let's now split that into another tower. And it just becomes a really big management nightmare. And a lot of providers handle that with like VPLS or some kind of layer 2 tunneling back to a central point, but it kind of brings the same problems of common L2 domains and just stretches them on potentially even larger and more and larger fault domains that might be a little bit more fragile.
That makes sense. Another topic that we discussed is, and this is described a little bit differently in this version of the slide deck, is as a network grows. So, Jared has shared publicly, here is some Python scripts, here is the way I've adjusted this open source software to meet my need. Is there a time and place to sort of graduate outside of, those kind of, one user supported OSS, BSS to, I know Anton, you were talking about there's different skill sets in your organization. Not everyone knows how to manage SQL clustering, how Anycast works, or how to debug Anycast, et cetera. And then similarly for for a NIC, you've got so many vendors and so many customer types that you have multiple teams that can handle this. So I'm curious, starting off again with Jared, is when do you see the justification for some more advanced, OSS and BSS tooling that can drive some of this logging, provisioning, et cetera?
Yeah, one of the things I've been doing is I've been trying to, even though Ubiquiti is a very interesting company, is I have been trying to provide feedback to them, both in their community support forums, and they have the ability for you to open up support cases as well, and try and drive some of the capabilities that I or others may have the capability of implementing. For example, if somebody hits a non-payment status or something, it used to be that my system might send them a bunch of nasty emails saying, hey, your service has been suspended. But because I wasn't using a Ubiquiti router, it didn't go and redirect them to a payment thing, because that's the way their platform had been built. And especially on the fiber side, I actually got them to add in the feature to be able to just disable the ONU. It would have been nice to have it maybe go to a quarantine VLAN or something like that, where it could, captive portal them. But it's just no, we just disable the ONU. Well, of course, in doing that, they didn't always complete the second part of the workflow, which is once they pay to unsuspend the ONU. So they did.
Well, they just come knock on your door, right?
Well, they did exactly what I requested from a feature request perspective. So been doing that, and then trying to find other people in the community as well, so we can say, okay, let's build this tooling or tool chain. And that's why I shared some of the configs, is because I've looked at the Kia configs. I've tried to figure out, okay, how can I replicate what I can do in the ISC DHCP daemon into Kia, and not everything translates one-to-one. Right. And because of that gap there, I'm kind of stuck in this in-between space. And a lot of people, who use, free open source software in their platforms, be it, Junipers, the Ciscos, or whatever, who may have that in there, they're quite possibly going to have the same thing where they're, integrating these things for a long time, just because that's the way this ends up. I've seen it play out already for a couple decades now. So you're going to see that same software stack, and now you've got the ability to say, okay, let's build, here's the configs, this is how to do it, and then, people can figure out how to, tie that all together. There's nothing stopping me from going and taking the Ubiquiti UISP platform, the Junipers, collecting data out of, from a streaming telemetry of here's the MAC address tables, here's what goes to this port, here's all the NDP information, all the ARP information, and pushing that in to, the CRM software. But I've not hit the point where that's become a necessary thing to do. The most common things that I see are, hey, somebody, changed the cabling in their house and they plugged in the PoE injector backwards, and they're offline, or they plugged the routers all in, but they didn't hook up the cable from the PoE injector to their router. And so it's the class of problems that we run into, those are things that we could clearly communicate back to them. Oh, we're seeing you're only negotiating at 100 meg, or we see, but we saw you were a gig a week ago. But actually communicating that to the customers, a lot of them don't know they don't know what to do with that information. And so unless you're already in the area willing to make a service call, it's not been a big deal. And then, I haven't seen any lawful, if I had my transparency report, I've seen 0 requests from law enforcement to date, and I hope that doesn't change. But, from that perspective, I haven't had to go back and dig through, decades worth of logs to figure out who was using this IP on Tuesday.
Yeah, I think one of the interesting things about smaller scale service providers, I often will see the trigger is when the founder wants to take a vacation. And so you'll outsource support, for example. And when you outsource support to, a third-party NOC, it's not going to be very efficient for them to fire up a Python script, look at 4 different sources of truth to try to understand and correlate a customer. But you live and breathe that. And one of the nice things is that you've put a residential gateway, or highly encouraged people, so you have an end device in their home, so you have some telemetry and ways to diagnose problems. I'm curious with Anton, where your demarcation is a cable. Do you try to have a Wi-Fi router that you have some more of that control? And again, in your organization, you're doing a pretty advanced setup. How have you been able to spread the love? So again, it's not your cell phone always.
Well, so this is, try it, see what happens. Take the feedback seriously from customers might be the first thing I'd highlight here. And the evolution of all this stuff that's on the map there today begins in 05, 06. So we've got a decade plus, if you will, in the backlog here. And the history of this tells me that when we tried to do things like, I'm just going to pick on managed Wi-Fi for a minute, because that was a huge mess. We tried this so many times, different ways. We had we had projects with the University of Wisconsin-Madison even to help build in some telemetry. There's a thing you'll find on the web called Paradrop, containers on Wi-Fi AP routers to do exactly this sort of thing. So imagine a team that was working with my company and full of PhDs and very capable CS folks, and it's a hard problem. And the solution was just really push IEEE to get Wi-Fi 6 going out there and push everyone to .ax. And all of a sudden, subchannelization made the problems go away for the user experience. Now, this doesn't address, oh, why is my game not working? What's up with UPnP? Anton, you destroyed my video chat.
Right,
that kind of stuff
isn't working or something.
Exactly, but the basic access, like does physical layer get me bits and is it enough to play Netflix? That was a better problem to push to other organizations like IEEE, honestly. All the coordination and channel, collision avoidance and stuff just didn't really actually help at scale. So technology was the fault here. So I guess what I would say and summarize by saying is that maybe the best job any provider can do is figure out what the problem really is. And is it having a CPE that I can talk to or not? And in most cases, for us, it has not been. And I want to highlight some major failures right now in competitive markets like ours in Madison. One thing that wins away from, for example, AT&T GPON is the fact we don't have RGs. Because those are 8,192 flows limited, and that's it for some interesting reason.
Right.
I'm sure it's a good one. I'm sure someone had a reason for that. And it runs speed tests in the background. And if you're a, radio station or media interested group, or even someone who just uses Hangouts all day or Chime, you're going to really not like having latency bumps randomly throughout your call. I'm guessing, just hazarding a guess. So how about we don't do any of that and try to have good CSRs and good customer support responses. And so to the point of this, yes, a green light on a switch port doesn't tell us how good the cable to the unit is or whatever. But we can infer some of that with some speed test results, some fast.com results. Does this work? Does that not work? Okay, refer it back out to the building maintenance people, whatever that might be. And so for the majority of the response patterns, we've seen and shied away from more active stuff to just break, it seems like.
That makes sense. If there are folks that have questions, if you want to line up, we're going to continue on here with Nick.
Yeah, so
again, that graduation of shell scripts to some more advanced tooling.
Well, he said he's got a whole tooling team that works for him.
Several tooling teams.
Yeah, so I mean,
OSS, BSS for him.
Yeah, we have all kinds of tools for all kinds of things. If you need to look up a customer by IP address, we have APIs and web interfaces to do that. There's all kinds of tools that help support at scale, and I think that's the biggest thing is when you have a lot of customers and you have a lot of CSRs, you can't expect super advanced technical people at that kind of scale. And so we try to make it as easy as possible for people to get information and troubleshoot the customer as they can. And in our deployment model, having the kind of detail that we get and being able to tie sessions directly to a customer and directly to a device really do help us support the customer.
And you're not forcing a residential gateway or a Wi-Fi router?
No, we do offer one, and it does make support, I would say, easier for us. Definitely, I agree that a lot of the residential gateways that ISPs, including ourselves at the moment, offer are not the best, but they do allow a lot more remote troubleshooting, and speed tests are something that are actually valuable for, users can't reliably speed test to, reliable speed test endpoints, and they can't, sometimes it's hard to communicate that, what speed test method are you using? Are you using Ookla? Are you on a, 20-year-old computer that can't support the CPU load in the browser? You never know. So if you can run a speed test to a device client that's plugged in, at least you have that data and you can use it to help support the customer.
Yeah, I've definitely seen a lot of those devices now allow the operator to remotely trigger that speed test and give it some additional settings. At least the state that I'm coming from, California, our regulator, if you're receiving a grant from them, they require you to use a non-UCLA speed test with very specific parameters. So having a way to remotely do that and not drive around is really important. Are there any last points that the panelists would like to share in terms of their growth of their provider and how they've adjusted over the years? Any wisdom in our last 5 minutes and 30 seconds?
I'll say as a small provider, it's been, standardization is really important. I'm at the point now where we have almost, for the number of customer networks out there, a significant number of them are using, the Aero devices. They work out relatively well overall, and having that consistency across the, the subscriber population helps a lot, especially because it does have that built-in speed test capability, and it tends to not have a lot of the negative consequences of a lot of the other, mentioning somebody else's like residential gateway and limits. And so having something like that, I found it more helpful than I thought it would be, because I originally wanted to be a lot more technical in how I did it, and I had to realize, like, no, keep it simple. And customers, they want it like, you would say your refrigerator in your house, right? They want refrigeration as a service, or they want, internet as a service. They don't even know that what they're asking for is internet, because they say the Wi-Fi is down. They don't say the internet is down,
Right.
The Wi-Fi is down.
Right.
Yes.
It's Wi-Fi. So before we go to the mics, I want to add one thing here, Matt. One thing I would share with others who are in similar scales, 10, 50, maybe 100,000 kind of customer scales, one thing that really helped things stay, I think, together this long is not do silly stuff like offer and provide more than basic services for IP access. I can't even count the number of times folks have asked for Metro VLAN support, layer 2, everything, whatever. And if we push them to IP, they tend to do things that I think are virtuous, like VPNs with IPsec and shared certs, or something like that, or WireGuard, or anything not layer 2 open to your provider. Please don't show me anything.
Right.
Right. These are patterns I think I can embed by just saying it's all IP.
Right.
All day. So point number one is try to pick something that you can ride for 20 years, and this is what IP has done. Second point is, as Jerry was mentioning, I will echo that in spades, and that is KISS. Keep it simple, stupid. It should plug and play. The thing you expect to have happen from the customer's perspective, please just do it. Always work when it should work. And don't go down when they do it backwards. Plug a router in funny. Poison the local DHCP discovery mechanism. So that kind of thing, just the provider is invoked in and should do things to minimize that. We call it blast radius or problem scope or whatever, but it really is, does it work how I expect? And if it does, then it probably follows these good patterns, I think.
Great. And Nick?
Yeah, I'd agree with that. I mean, we do actually try to keep things as standardized and as simple as we can. It is a core part of what we do. We try to, but with a lot of, legacy tech debt and a lot of different generations of hardware that have been deployed, we started as, buying the Northwest assets from Frontier. So we have had a long running history of a lot of technologies, and ultimately any business is going to have something like that, and you're going to have to still be in an architecture where you can support, changing technologies.
That makes sense. We've got very minimal time, so if you can make the question pretty quick.
Sure, thanks. I'm Nathan Penny from Telmax. My question is kind of related to CGNAT and V6, especially when you let your customers pick their own gateway. We kind of see that as a way to enable V6 for them. So I guess my question would be, how are you enabling V6 with this? And then the other kind of question is, how do you manage Resi statics? I think that was raised earlier, but I didn't really get a clear, at what point do you move them? I think Anton's answer was keep it simple. I get that, but some people just are Resis who want statics.
I'll hit that quickly first. For statics in this network I'm describing here, for most of the non-business customers, business is ICB, so we kind of put that to the side. That's maybe a 1 in 100 kind of ratio compared to the Resi side. When it comes on the Resi side, that is through DHCP, looking for specific port binding options inserted by the 82 relay. So anything on that port, if you will, gets the IP address they should get. confounded by multiple MACs. If they switch routers, it might take a second for the backend to figure this out. But that table structure that drives the association will give you that address for the combination of switch hostname, relay agent ID, and physical port bindings to it. Not, I shouldn't say physical, but the VLAN it comes in on, meaning it goes to unit number X in building Y.
Gotcha.
Yep.
And what about V6 in your topology where they don't provide their own gateway? Do you use V6 or do you see that like opted in?
Well, so that is also through DHCP, and depending on the compatibility and the behaviorisms in the thing they plug in, they may have it work and it may not work. The solution in the MTU space and MDU space also hint to other providers trying to do this, even our competitors. Just put some working gear in maybe the property manager's office or in a small, I don't know, little free library of hardware in your building. Maybe a couple USB adapters, other sorts of things that help you get through those rough patches when your support can't physically do it and it really is an equipment problem. That sort of simple, low-cost stuff seems to have really given us a lot of mileage on that front.
Thanks.
Welcome.
We have one more quick question.
I was here. Picking my. You can go ahead if you want, sir.
Yeah, thank you. I'm reading out the remote question from remote participants. So Prasatyananda is asking, how do you guys perform an RFC test, for instance, benchmark test in your infrastructure to ensure your service is provided according to SLA?
I think the question is how to do performance testing. And I think most folks have mentioned on the panel here that if there is a device that is provided by the provider, so it could be customized for the particular carrier, or it could just be a mesh retail device that they can trigger a speed test with that.
The Arrow devices, that we will set up and we will retain some management access to until a customer kicks us out. What we found, I've actually found that customers don't even take over management of the device. If we try and transfer it to them, they won't. So we end up owning it by default, which I think annoys Arrow even more. But that's a whole separate thing. But like we can trigger a remote speed test, and then hey, here you go. Here's the speed test result, and they can see that. And they also seem satisfied with seeing a speed test result for their service, not necessarily that it's to their exact device, but this is the speed at your home.
Okay, we'll be very quick. So there has been an initiative by the government.
Which government?
United States of America.
Okay.
Right. So the funding initiative is actually providing some, funding to provide the fiber to homes in United States. Mm-hmm. And I guess the service providers, as you guys, internet providers, you should be aware of that. So I would like to have two questions, but it's in conjunction with the, related to each other, I would say. So one, you may use a different vendors to, implement your solution. And as a baseline, there shouldn't be any difference. But if you have different vendors and then thinking about this fiber to home connection, providing a connection in a simplicity or in a better technology, if you highlight one item that what could be better for your future, simplicity or technological improvements that you're expecting from the vendors, considering the a little bit differentiation between the vendors, I would say.
Yeah, so what I would recommend for folks that are either watching the stream or in the room, there is a survey that occurs for all talks. And I believe that bringing some of this access layer networking discussion back to analog could be quite useful. And we have many other items that we would like to discuss, such as how some of those funding mechanisms can be used in a standardized way. But unfortunately, we're over time. But feel free to come up, after the panel closes. I don't want to keep people away from the cookies and soda.
No worries, no worries. Thank you so much. I guess for the next analog, I will present this topic then.
Sounds great.
I'll just say, reduce complexity. That's the single biggest thing I'll say. You make it easier to deploy the technology. It's the same for the consumer as for the ISP. Yeah.
I want to thank the panelists for sharing their insights, and that's it.
Thanks, Matt. Yep. Thanks, everybody.
Thank you for the great panel discussion. And we really appreciate your contribution.
you.